First question, we have a function here. It tells us x is not equal to 3, so that's probably a hint that there's an asymptote at x equals 3. Write down an equation of the vertical asymptote, in other words, when the denominator is 0. So to calculate a part I, we need that 3 subtracts equals 0, gives us x equals 3. You must write the x equals. Horizontal asymptote, so limit as x tends to infinity of f of x. Divide numerator and denominator by x, that's the bias power, so it becomes 2 plus 4 over x over 3 over x subtract 1. And then when as x goes to infinity, this goes to 0, this goes to 0, we get left with 2 over negative 1, which equals 2. Asymptote is y equals 2. Part B, find the coordinates where the graph of f crosses the x-axis. So part I, we need that y equals 0, implies that 2x plus 4 over 3 subtract x equals 0, implies that 2x plus 4 equals 0, which implies that x equals negative 2. And the y-axis, x equals 0, gives us y equals 2 times 0 plus 4 over 3 subtract 0 equals 4/3. Y equals 4/3. So it wants coordinates. It says coordinates here, so I better put the coordinates. The coordinates here are negative 2, 0, and here is 0, 4/3. Sketch the graph. I'll just take the equation 2x plus 4 over 3 subtract x. So now we have these points here. It goes through negative 2 and 4/3. So x is negative 2. It's about here, and 4/3 must be here somewhere. We've got asymptotes at, I can see the asymptotes at 4/3. And this was, where was the y version, 4/3, so sorry, no, asymptote is at y equals 2. Y equals 2 is our asymptote. Mark that as y equals 2. And, oh, sorry, negative 2, that should be negative 2. Y equals negative 2, that should be better. Erase this. Put in y equals negative 2. And x equals 3. And then we just need to check, put a large value like 10, we get 24 over negative 7, so that's negative, so it needs to be negative here. It can't cross the axis here, so if it's negative here, it must go like this down to the asymptote, so it should go like this. And then here in this bit, it has to go through this, it has to go through here and here and up to the asymptote, so it must come down through here like this. So it must come down here through these points and down there. There's my sketch. Function g is defined by this, given that g is equal to the inverse of g, so I need to make this equal to the inverse. Let's find the inverse. That means that g, so invert the x and y's, x equals ay plus 4 over 3 subtract y. Make y the subject, multiply by 3 subtract y. Expand the brackets. Get everything with a y on one side, so these two have to be one side, these happen to be others. Let's put the y's on this side and the numbers on the other side. So add xy to both sides, I get an xy plus AY, subtract 4, 3x, subtract 4. Factorise, we can swap the sides, but factorise the y out of the x plus a equals 3x subtract 4. Divide both sides by x plus a. So g inverse of x equals 3x subtract 4 over x plus a, which equals g of x, which equals ax plus 4 over 3 subtract x, which means that this and this should be identical. The issue is that x there is a negative x and that 4 is a negative 4. So let's say inverse g of x, multiply numerator and denominator by negative 1. So we get inverse g of x equals negative 3x plus 4 over negative x subtract a, which equals ax plus 4 over 3 subtract x. If you look at that, for that to work, the number in front of the a must be negative 3. Does that work? Put negative 3 there, get a positive 3 there, yes. So therefore a equals negative 3.